Hi there, this is Jacob Nash Engineering Lessons, and this video is going to be about moments, standard 2.1.5 on Unit 1, and this is Unit 1, 2.1, Lesson 12. So, like I've said before in other videos, this is the longest unit, likely, um, and if you've been watching these videos, thank you for doing that, and I apologize that some of them have been long and the first one had no sound, but um, this is important if you want to understand these topics. And I do now know how many lessons there will be left. There will be after this one there will be three more. One on how to complete activity 2.1.5, one on trusses, and then one on activity 2.1.7. Now, you might say, hey, why not 2.1.6? The way that the course is going, as far as what I'm teaching, is not covering that part. So, sorry about that if that's what you need, but I'm not making video on that. So, let's get started. What are moments? Let me take this away. Moments, well, we talked about these briefly in Unit 1.1, Simple Machines, and also in the energy unit also. Moments are a measure of the tendency of a force to rotate the body upon which it acts. So, how likely will it rotate on its body? The formula for finding a moment that we've already learned, but if you are doing your units differently than the way that I've taught them, then you might not have heard this yet. But M equals D times F, where M is moment, D is distance in feet or meters, and F is force in pounds or newtons. So here's the deal. As we see on this page, there are certain units of force for the moments that you need to choose based on the way the problem is set up. So there are two types of units that are discussed: English customary and SI. For English customary, the force of the unit of force is pounds of force, lbf, or sometimes just lb. And then the distance force or unit, is foot, ft. And then when you multiply the two units together, they become pounds feet. For the SI, you use newtons for the force, meters for the distance, and the moment unit will be Nm, newtons meters. Sometimes you have to convert, and here are different ways to convert. These are four different things that you'll have to do. You'll have to convert to centimeters to meters, and you can do that by dividing the number by 100. You can convert from inches to feet by dividing by 12. Now you might think, do I have to do it from feet to inches? No, because your units always have to be in pounds feet or newtons meters. You have to, that's what your answers have to be in when we're calculating these. To convert from meters to feet, multiply by 3.28. To convert from pounds to newtons, multiply by 4.45. Now, if you have to do feet to meters, wait a second. I think I did something wrong. Well, you'll have to convert from feet to meters, and you can do that by dividing by 3.28. And if you have to convert from newtons to pounds, you divide by 4.45. Arrow keys aren't working today? Okay. Rotation directions. So, like we said, moment is a tendency for it to rotate. If it rotates clockwise, then the moment will be negative. If it rotates counterclockwise, then it will be positive. This might seem confusing because you'd think that clockwise would be positive and counterclockwise would be negative, but think of a coordinate plane. If you go counterclockwise into the different planes, that's how it's positive. That might not make sense, but that might be a way to think of it. But if that doesn't make sense, just remember that. So let's do our calculations now. This isn't activity 2.1.5. These are just practice examples. Calculate the moment of a longer wrench. So this is a longer wrench. That's what it's called. Well, this one's pretty easy. Formula is, like we said, M equals D times F. We have to figure out what those values are. They say 1 foot, 20 pounds. Do we have to convert? Well, here's how you can tell. The answers we said have to be in pounds feet or newtons meter. So since we got both pounds and feet, we don't need to convert. Now we can solve. You might think at first that you're supposed to do 1 times 20 and that the answer is 20, but you have to add a negative sign there. And 1 times 20 has to be in parentheses because if you see, this is going to be rotating clockwise, and we said clockwise was negative. Now this arrow thing is here, but sometimes that might not be there. But how can you tell if it's going to rotate clockwise or counterclockwise? Well, see this red arrow? It's going down. Think about the way they will rotate, like this. Since it's going down, it's going to rotate clockwise. And if you don't know the difference between clockwise and counterclockwise, well, it's called that because that's the way a clock goes. Think of the way the hand goes on a clock. If it looks like the way the force is going, because if you think about it, the hand seems to go down as it reaches 1, 2, 3, 4, 5 o'clock. So that's how it's clockwise and then negative. So that's why I had to add a negative there. And then we get negative 20 pounds feet. That's our answer. Remember, that's the unit. Now let's do an L-shaped wrench. A little bit more complicated. Here's how you can do one like this. Once again, we have our formula. Let's find the distance and force. The distance says 5 inches, but we can't use that because, like I said, the answer has to be in either newtons meters or pounds feet. In this case, it'll be easier to make our answer in pounds feet because you would have to convert this into feet and then meters, and that's just 2 steps instead of just 1. Well, you'd still have to convert that to meters, but or not meters, pounds. So since it was in it's 5 inches, we have to convert to feet. Like I said earlier in the video, you can divide by 12 to get to feet. That's 0.42 feet. That's what our distance is. Now force, we need it to be in pounds, not newtons. So we can multiply it by 4.45. That's our conversion factor. And we get 26.7 pounds. Now we multiply, but once again, we need to have a negative sign because it shows here, but even if it didn't, once again, this arrow is pointing to the right. Think about what would happen if you pushed it to the right. You're cranking it down pretty much. This part would come down and it would go clockwise to wrench in this bolt. Now you might think, hey, why didn't we oh sorry, well there's the answer, that negative 11.21 pounds feet. That's what we get. But you might say, hey, we didn't use that. Well, you don't have to. That would be used to solve a different kind of problem that will not be taught by me in these videos. You may have to know it, so ask your teacher if you have to know that. But in this case, we didn't have to use that. You just solve the same way as this wrench, even though it's a little bit different. Now for the Z wrench, it's a little bit different. Let's see. That's our formula. We need to find the distance and force. How can we find the distance? Well, we need the total distance from, always you need to find the distance from the point where it will rotate and from where the force is. So we have 8 inches plus 10 inches is 18 inches. But then we can't have it in inches, remember? So we have to divide it by 12, and then we get 1.5 feet. And we didn't have to do anything for the force this time. It's already what it can be. Then, once again, negative, because if this pushed down, it would rotate clockwise. And our answer would be negative 30 pounds-feet. Now, I have to note that I'm pretty sure that I know I did. I changed the numbers for this one, so it might be different than on your problem, so keep that in mind. I only changed it because I wanted you to see how you could convert from inches to feet and then newtons to pounds. Okay, now wheel and axle. Okay, what can we do? Well, still the formula's the same, but this time when you go to find the distance and force, you might say, hey, I don't see anything that says distance. Well, the radius is the same thing as the distance in this case, so you can use 50 centimeters. But if you remember, since this is already in newtons, it will be useful for us to use the units of newtons meters. So it can't be in centimeters, so to convert from centimeters to meters, you divide by 100, and you'd get 0.5 meters. Didn't have to do anything for the force. It's still 100 newtons. This time it's positive because where's the force coming? It's coming down, and since this force is going down, think of someone just like slapping that end of that, and what would it do? It would go this way. Even if this arrow wasn't here, you could tell it would go clockwise, or sorry, counterclockwise, and that is positive. So we get 50 newtons meters. Now let's calculate the moment of this wheel and axle. So this time it's a little bit more complicated, as you can tell. Don't get stressed out. You can still do it. So we will use our knowledge of vectors in 2.1.4 to solve this one. Same formula. Distance is same thing as the radius. It's just the same thing as last time. So we have to convert it to meters by divided by 100, 0.5 meters. Now, here's how we can find the force. If you notice, that thing's going to keep coming up, but look down there. The force we're given is 100 newtons, but that's not right. That's like diagonal. We don't want that. We want straight down. So that means we need to find Fy. That's what it says right there, Fy. So we remember from our vectors unit, we have to use either sine or cosine from the angle's perspective, and Fy is opposite to the 50-degree angle. That means we'll use sine. So force times the sine of 50, the force is 100 newtons that we're given, and sine of 50 turns out to be 0.766. When you do 100 times 0.766, you get 76.6 newtons. That's our force. Then, once again, it's positive. This time that thing wasn't there, but you can tell it's positive because it goes down. Hit that thing down, and it goes counterclockwise, which is positive. And then you get 38 newtons meters. Rotational equilibrium. We talked about this a little bit in 2.1.3, but this is the state of where a body, well, we know equilibrium means it's balanced and it's not moving, but in terms of moments and rotational equilibrium, it's if it is if there's no motion or a constant motion. Hi there. Sorry about that. The video turned off because there's a 15-minute limit for Screencast-O-Matic. So I had to use screen something. I don't remember what it's called. So I have to do this quick because that has a 5-minute limit. So rotational equilibrium, well, I just said what that was. And then that means that if a body's in rotational equilibrium, the sum of the moments will equal 0, meaning that moment 1 plus moment 2 plus moment 3, etc. equals 0. So we'll use that equation to solve these next couple problems. So in this problem, we need to find d2. We'll use this equation. We can actually change the equation to moment 1 equals negative moment 2 by subtracting that, which means that distance 1 times force 1 equals F2 times distance 2. So we can plug in our values that we see here, and it needs to be negative because we actually we subtracted F2 times D2 and put it back on there. That it's kind of a strange way that PL2W did it. But then we have it back on the other side again after this step. So we need to get D2 by itself. So we have to divide by 40, which means that the 40s will cross out, and D2, that leaves us with D2 equals 100 divided by 40, which means that it's 2.5 feet. That's how you solve that problem. So for this one, we need to find RAY, and R represents resistance force in this case. We can use this equation again. This time we'll use B and C instead of 1 and 2, because that's what's given. We can change it like we did last time, and we get this equation. We plug in our values, and then we come down here and we're trying to solve for our BY first, because that's the value that we need to find first before we can find our AY. To get it by itself, we need to divide by 10, and we get that our RBY is 10.5, and then we can use the equation that RAY plus RBY equals 35 pounds, meaning that 35 minus 10.5 will equal our total, or subtracted amount, that is 24.5 pounds, which is what RAY is. So that's the end of this video. Thank you for watching, and please see the next video about how to solve activity 2.1.5. Thanks for watching.